All right, so a Lazy Susan food tray is being rotated by a person in quest of sustenance. Suppose the person exerts a 2.5 Newton force perpendicular to the Lazy Susan's radius for a certain amount of time, okay? So if I'm thinking about what's happening here, so I have this disc, right, and this person is applying a force to it, okay, in some direction, okay? If I think in terms of regular linear stuff, right, the impulse is the change of momentum, or force times time would be the change of momentum, right? Okay. If I want to make that angular, right, it's going to actually be torque times time is going to be the angular change, right? So I'm just putting everything into angular, okay, which basically means I'm multiplying by the radius, right? Torque is force times radius times time, and this would be L final minus L initial, okay? But they say that's 0, okay? So to find the angular momentum after, I just basically have to multiply the force times the radius times the time that it happens, okay? And then that turns out to be 0.0975, okay? Newton meter seconds, okay? Or I guess we could call that joule seconds. Do we call that joule seconds? If I want to do that, let's just call it Newton meter second for a minute. I need to check on that, okay? I think actually, or joule second is probably fine, okay? All right, okay, so that's part 1. I'll check the units on that. Okay, and then what is the final angular velocity of the Lazy Susan, given that its mass is 4 kilograms and assuming that it is a disk, okay? So remember, the disk moment of inertia is 1/2 mr squared, okay? And the mass they're telling us is 4 kilograms. The radius was 0.26 meters squared, okay? So 0.5 times 4 times 0.26 squared. Okay, so the final, or the moment of inertia is 0.1352 kilogram meter squared. Okay, and then putting these together, if I want the omega, right, because angular momentum is I omega, just like P equals mv, right? Like there's the linear version, okay? So omega is just going to equal L over I. This is 0.0975 over 0.1352. Okay. All right, so 0.0975 divided by 0.1352. Okay, 0.72, and then this will be in radians per second. Right, because this will be Newton kilogram meter per second squared, right? So then that's going to cancel all of those, right? And then I'll just be left with 1 over seconds, which is basically a radian per second. Okay.